Tonight, Jim, AI5EG, will be presenting the main topic presentation, Standing Wave Ratio, or SWR, what it is and what it isn't.
All right. Thank you, Bill number 9 and the entire Tech Net team. Welcome to our Tech Net number 15. My name is Jim. My call sign is AI5EG, and I live near Harwood, Texas. So we're going to talk about standing wave ratio, and it's going to be in 2 parts. First is going to be just basically what is SWR. There's really voltage standing wave ratio, or VSWR, but we say SWR. And then secondly, we'll cover what it is not and some misconceptions and when it's useful. There's a little jargon, impedance and decibel or dB. They're explained in the last slide, so if you want to take a look if you don't know what those are. And any others you may run across or I mentioned, feel free to ask me. This is AI5EG. So our goal as ham radio operators is all our power to go out to free space and to galaxies far, far away. And so conversely, we want all our received signal power to come into our receiver. So SWR basically cuts both ways, or the idea. So the question is, how does SWR help us with this? And I'm going to go to slide 3. On this slide, I have a graphic that's on the website hamradioschool.com. And there's at the top from your transmitter, your power is going along your feed line or coax toward the antenna, and it's represented by this blue voltage wave. And most times, like an echo, the red dotted wave, some of that power that doesn't go into the antenna gets reflected back. Now, these oppositely traveling voltage waves on the feed lines, they travel in opposite directions, passing through each other, and their voltages add together. And the solid red line in the graphic is the result. When these 2 waveforms are in phase, in other words, the peaks align, their voltages add together to a higher voltage than even the forward voltage wave. And when they are in opposite phase, they add together to a waveform that's actually less than the reflected wave. So if you look at the graphic, the standing wave ratio is the ratio of the maximum voltage to the minimum voltage of this wave that appears to be standing on the feed line. It's not moving. So you take the voltage at number 1, divide it by number 2, that's what a ratio is, and that's SWR. AI5EG. The more reflected power, the less power is going to the antenna, and the SWR is going to be higher. The less reflected power, then more power goes to the antenna, and the SWR is lower. So there's an example on slide 4 that just shows what the voltage would look like if you were to put an oscilloscope on your line and had it all set up correctly. So you see the waves, looks pretty mixed up, but you can see the peaks and the valleys. So this is AI5EG, Tech Net number 15, I think. And that's it. That is standing wave ratio. That's all there is to it. So we're moving to slide 5. I need my glasses. So what is SWR really? As human beings and experimenters, human nature, we want to improve everything we can measure. And I, myself included, we obsessively pursue the 1-to-1 SWR as low as possible. So if you have a 50 ohm source like your transmitter, and you have 50 ohm characteristic impedance coax, to get the maximum power to the load itself has to be 50 ohms resistive. And in that condition, you will have a 1-to-1 SWR, and all your power, except for anything losses in the coax, will go into the load or your antenna. For example, dipoles and verticals, when they're at resonance, they have an SWR of approximately 1.4 to 1. So, and also I have a very good dummy load that has an SWR of 1 to 1, pretty close. So at this moment in time, I would like to turn the net back over to bill number 9. If anyone has any clarifications they need about what actually is SWR, we'll continue in a minute with more details about it. But if there's any clarifications or jargon or anything like that, please ask. Bill number 9, turning it back to you.
Thanks, Jim. This is 85LK Net Control for the Crossroads Ham Radio Club Tech Net number 15. We're talking all about SWR. So any questions or comments so far for Jim? Please come with your call sign now, please. Go back, I think it's slide 2 or 3, where we show the waveforms. Yeah, there. What might cause those waveforms, maybe there's too technical question, to become in phase or out of phase? Is that with the coax, or what might cause that? Your thoughts?
All right, Bill, good question, really good question. So what's going on is the blue wave is traveling to the right in this diagram towards the antenna as you transmit. And we're showing a sine wave like it's CW. And then when it gets to the antenna at the speed of light, some of that power is reflected back, and that's that red dotted wave. These are actually traveling continuously in opposite directions. So they're not traveling in the same direction. And when as they travel in opposite directions, their voltages add, and that's going to be the red superimposed combination wave. That's the wave you can see. You can't directly see or measure the blue or the red dotted wave with a scope or anything like that. There's other ways to determine them. Does that answer your question?
Yep, it sure does. Thank you. Thank you, Jim. Any comments or questions for Jim? Please come with your call sign.
W5ITZ.
Good evening, Bill. Go ahead.
Yeah, good evening, everyone, and thanks for a good start, Jim. In reference to the signals being out of phase, would a non-resonant antenna have anything to do with the signal being out of phase?
Okay. You may be trying to ask a very deep question. If so, grab a life preserver. But the fact is, the waves are traveling in opposite directions. They're continuously going in and out of phase. It's like if you were to see a seawall and you see the wave hit the seawall and come back, you're going to see some waveforms out in the water that are just up and down, basically. So the standing wave is formed by waves that are traveling in opposite directions. So whether they're in phase or out, they go in phase and out of phase like constantly. Now, if you have a non-resonant antenna, it's not all resistive. So the phases, the SWR will still be the same because you'll still have the minimums and the maximums occurring along the feed line. So basically, it doesn't affect whether it's resonant or non-resonant. Doesn't affect the measurement of the SWR. I hope that answers the question.
Yeah, Jim, that's helpful. And just one more comment. You mentioned that the dummy load is 50 ohms. So that would almost make it a perfect antenna, right? High.
Yes, high. Right. It's a pretty good example of SWR is not necessarily the best measure of an antenna.
A5LK. Jim, can you go over just a minute Bill just mentioned slide 5 there. Just talking about those kind of those takeaways from the bottom there, because those can really kind of slide by everybody. Just those SWRs for a typical antenna. Can you kind of comment on those again? Then we'll move on if anybody doesn't have another question or comment.
Certainly. So if you have a 50 ohm resistive load, and 50 ohms is not a magic number. I think Chris, more than a year ago, went over why 50 ohms was chosen in his presentation, antennas 1. But a 50 ohm resistive load will absorb all the power, in theory, coming from your 50 ohm coax connected to your 50 ohm RF source. They could be a different number, but that's what we chose. And that'll give all the power to the antenna, nothing gets reflected, and therefore there's no red dotted wave, and therefore the ratio is 1 to 1. A dipole antenna at resonance, the key word here is that resonance is 72 ohms, and if an antenna is at resonance, you can take the 72 and divide it by 50, and that'll give you your SWR right there. And a vertical antenna is typically 36 ohms, so you do 50 divided by 36, you do it upside down, and you get 1.38 to 1. So that math only works for antennas that are resonant. If it's not at resonance, then you have to do more math than you probably want to do here today. Does that help?
Absolutely, sir. Thank you, Jim. Anybody else have a comment or question before we move forward? This is K5LK with Tech Net number 15, along with Jim, A5EG.
W5CPO with a question.
Hey, Bill, good evening. Go ahead.
So talking about resonance, Jim, is not resonant antenna the lowest impedance is where it's resonant?
Okay, you're getting kind of deep. So antennas are resonant when the capacitive reactance and the inductive reactance are equal. So many antennas can be resonant at more than one frequency, as you know. You can actually have a lower SWR with a non-resonant antenna if the antenna is naturally resonant at something other than 50 ohms. But it's just saying something is resonant, it basically simplifies the math for what we're trying to do today. Maybe we could go over that in another Tech Net, or maybe after the Zoom session, discuss it some more.
Sounds good, Jim. Thanks.
Bring your life jacket if we're going to talk about it.
All right. Good start. Jim, I'll let you identify and move on with the presentation. This is K5LK, Net Control for Crossroads Ham Radio Club, Tech Net number 50.
All right. Thank you, Bill number 9. And as Bill number 1 always says, your license is a license to learn. And I've actually personally learned quite a bit just doing this presentation here and there. So some of the history prior to World War II, most hams used ladder line. You can see a picture of it there. And some still do. I'm sure there may be some old timers on the net tonight that have some ladder line or remember it. Ladder line has very low loss, so mismatch in SWR wasn't a big concern, but it's, as you can see, it's unwieldy compared to coax. After World War II, with the invention and prevalence of war surplus coax, my dad had many reels of RG8U. He was a Mars coordinator, I think, for all of Area 5 back in the day. So we got this coax for amateur use, and today there's many tools to measure your SWR. Got it in your rig. You have a standalone SWR meter like I have. All the cool kids have a rig expert. The rest of us have an NOVNA, and there's other ways to do it as well. This is AI5EG. Some misconceptions about SWR. You're not getting out because your SWR is 2.5 to 1 or something like that. Too much power coming back, not enough getting into the antenna. 2 to 1 SWR might mean you only half your power is getting out. Some will subtract the reflected power the reflected power from the transmitter power to determine usable power. And if I feed my coax with a lot of SWR, the reflected power is going to my transceiver. And I have an asterisk there because I have another discussion on it in a minute. I don't want my coax to radiate. One that I've heard several times, even on the radio and internet, I hear it all the time, is antenna with a 1-to-1 SWR is going to work better than one with, I'll say, a 2.5 to 1 SWR. Basically, to measure antenna systems or compare them, SWR is not the answer. So it's just not the answer to do that. This is AI5EG, Crossroads Ham Radio Network. So, well, what's it all about then? Notes up here. Now, if you see the graphic here from the transmitter at the bottom along the coax, your forward power is the big blue bar. So some of that power, hopefully a lot of it, is going to get transferred to your antenna and go out to free space so that you can talk to aliens or maybe somebody a county or two away. If it doesn't all go, then some of it is going to get, the rest of it is going to be reflected back towards your transmitter. Now, when it gets to your transmitter, it gets re-reflected back from the transmitter toward the antenna. Back and forth, as you can see. And the only power that gets lost in this round trip is what's dissipated in the coax because of attenuation or wiring perhaps close to the transmitter, but that's the only power that gets dissipated. So that's what happens when your SWR is not 1-to-1. So the power either goes to free space, which is a good, or it gets lost as heat in the wiring and coax. And so the moral to this story is don't cheap out on coax. Don't cheap out on coax. AI5EG, Crossroads Ham Radio repeaters, and we're having a discussion of SWR. So SWR needs to be reasonable. It needs to be reasonable. It can't be outrageous because high SWR will produce higher voltages on your feed line and can be very high and on your transmitter's output stage. Now, modern rigs will reduce the drive to protect those output transistors from the higher voltage that might exceed their transistor ratings. But they're designed to expect a reasonable amount of power goes to the antenna and some's going to come back. So a reasonable SWR will make your transmitter happy so that it doesn't reduce drive. And a tuner or your rig will also make your transmitter happy, but it doesn't change the SWR in the coax to the antenna or the losses that incur in the coax. But a low SWR makes your transmitter happy. That's basically the goal here. So this is AI5EG, Crossroads Ham Radio Club, and I don't want Bill number 9 to yell at me again for not IDing, so I'm doing it a lot. How does SWR affect the power to the antenna? It will certainly increase loss in your coax due to attenuation, a resistive loss of the reflected waves, but it's not as much as you might think. The difference in power through any coax line, good or bad, with an SWR of 2 to 1 compared to having a perfectly matched SWR, termination is imperceptible. 2 to 1 versus 1 to 1, the additional loss due to reflected power is less than humans can distinguish, which is 1 dB. Now, when I'm talking SWR, we're talking SWR measured at the antenna, not at the radio. So 2 to 1 is kind of like that borderline number. I mean, should I climb up on top of my tower to make it better? Probably not. This AI5EG, Crossroads Ham Radio Club repeater system. And for some final thoughts. SWR, well, before I do final, one thing I did think of after the slides is you should note and monitor your SWR for any changes, because the changes in SWR, whether it gets better or worse, can indicate problems with your antenna system. Something's going on that you need to investigate. SWR needs to be reasonable. SWR actually measures, it's a measure of how well your radio coax and antenna are matched to the 50 ohm goal. To compare antennas, comparing SWR is not the answer. Low SWR is good, but if we go like obsessive, like I do, we really are going past the diminishing return point. And again, as Bill number 1 pointed out, low SWR doesn't mean you have an efficient radiator. And coax is the most important part of your antenna system. Don't cheap out on coax or the connectors either. You can get cheap connectors, cheap coax, and you may not realize you could do better. So this is the end of the on-the-air portion that I had prepared. And I would like to turn it back over to our net control, Bill number 9, and for any further questions and discussions. This is AI5EG.
Jim, awesome presentation. A lot of good information in there. This is K5LK Net Control for the Crossroads Ham Radio Club Tech Net number 15. Can you go to slide 8, Jim, and then we'll open it up to questions and comments. The one that's got common misconceptions. I know you've got some a source there on some of that. Why do you think it is that there's so much focus on SWR? Where did that come from? And obviously, it's not that big a deal in a lot of installations, as you talked about tonight. It's more issues with the loss in the coax. But any thoughts about where kind of the history of some of these misconceptions and what's keeping it active today?
Yeah. Well, I mean, number one is it's the thing we can measure. It's pretty easy to design a circuit that will measure SWR, and so it does measure performance of your feed line and how well you're in a certain sense. But we just other things that are difficult to measure, and maybe we should have a session on it, like to actually compare antennas. What would be the best way to do it? Maybe we can have some discussion of that on the Zoom session. But I think basically it's tribal knowledge. SWR is important. You wouldn't want to have a 3 or 4 or 5 or 6 to 1 SWR because bad things happen, and it does cut down on the power going to your antenna. We can do some calculations, but just getting obsessive about it, and a lot of, I guess people pass along what they think, and I guess that's why we're amateurs. I don't know. Anyway, back to you, Bill.
All righty. Good comments. Thanks a lot, Jim. A lot of good information here. Okay, we'll open it up again to questions or comments. Please come with your call sign now. This is K5LK Net Control.
W5BSA with a question.
Go ahead, Joe.
Hey, Jim, Bill, can you go back to that one slide where it said just because you got a low SWR, does that mean you have an efficient antenna? That's what it said. So I've got a really nice antenna analyzer. So, Jim, what my question is, okay, so we're concentrating on the SWR and understand what you're saying then. So at what point, and how do you know if you do have an efficient antenna? If all we're looking at is SWR, where do we go from there to figure out if we've got a good antenna or not?
Okay, that is a fantastically good question, Bill. I mean, Joe, sorry. Fantastically good question. I have my thoughts on this. I would like to see if Chris is on. Do you have any thoughts on it? W5CUI, are you there or not there? Guess not.
He's not in the Zoom. I don't know. W5CUI, are you on RF? K5LK.
Sure.
Control.
To measure antenna performance, you really need to look at the field strength in different antennas. So if you want to measure antenna A versus antenna B, you need to get at a distance of at least 2 wavelengths, preferably more, and have a way to measure the field strength. You can do that with a spectrum analyzer or tiny SA or something like that, and then you can do an A versus B comparison as one way. Hard to do when you've got HF antennas to compare. The other way to do it is to actually model the antenna in some antenna design software, or basically you have to rely on the manufacturer. So SWR, just sticking the antenna on the analyzer by taking it off the radio, you're not even, I don't know how to answer that question. I just don't think it's a good way to do it. Anyway, a lot of the small handhelds are designed to work with the antenna that they come with. If you have a mobile setup where you can swap out antennas, like on an NMO mount, it could do those measurements. Might be fun to do at field day to do something like that. Anyway, back to you, Joe.
Thanks very much. That makes a lot of sense. I love the signal strength meter too. That's thanks a lot, Jim. Appreciate it.
Comment?
Comment? Go ahead. K5LK.
G5IAZ in Bay City. 2 other options is to listen to beacon stations. Beacon stations operate on a particular frequency, and they send a signal out at various power levels. And so if you want to go back and forth between your antennas, you can listen to the beacon stations to see which antenna works better. And I have not used them, but there are also reverse beacon stations where you transmit a signal out, and then there is a way through the internet that you can hear the signal that was received. So you can see what your signal sounds like, at that particular location. So that's actually bouncing off the atmosphere where you can actually check the propagation. So that's my comment, KG5IZ.
Thank you, Jim. Good comments, my friend. Glad to have you here tonight. That's K5LK Net Control for Tech Net number 15. We're talking all about standing wave ratio. More comments or questions, please come with your call sign.
SWR ITZ with a comment.
Let's a double there. Another station that double with W5 ITZ. Go ahead with your call sign, please. Wonderful. Double. Go ahead, Bill.
Okay, thanks, Bill. Jim, I just wanted to stress one thing that you said in your presentation, especially for the benefit of our newly licensed hams. I know there's a bunch of them out there, and we're sure glad that you guys are tuned in. Jim mentioned don't cheap out on connectors and coax. And guys, that's a very, very natural thing. I think most of us have done it. You start looking to set up your rig and you see there's some connectors available for $1.50 and there's others that are available for $5 per connector. And you think, oh my gosh, I'm going to save some bucks. And then the same is true with coax. You can get coax for 50 cents a foot, or you can get coax for $1 a foot. Do your research and understand why there's a difference in cost. And I can tell you, as one of the guys that made that mistake, bought the cheap stuff and got very subpar results until some of my Elmers said, no, you know, put the good stuff up, scrap your old stuff and put the good stuff up. It makes a tremendous difference when you're setting up a station. So save yourself the pain and the expense of throwing away that first investment, and do the research and get the good stuff, and you'll be far more satisfied with your station. Jim, that was an excellent point, and thanks for making it. W5ITZ.
Comment?
Bill, and go ahead, Jim.
Great comment, Bill. I have some cheap coax myself, but the coax that goes up my tower is probably the as good as I could get. So I would spend money on coax and save up for a better antenna. You can always use the coax later. And also using the beacons, FT8 is another great way. You can receive signals and get see the signal strength from a bunch of different stations, switch antennas, and compare from the same station if they're still there. It's a little tricky because you're also dealing with effects of the propagation, so you may not, you have to kind of get a feel for the effectiveness of your antenna. Anyway, that was my comment.
Okay, thank you, Jim. I think we had a double with W5ITZ. There another station that had a question or comment? Please come now. That's K5LK, Net Control. Try it again. I think we have somebody trying to check in. Do you have a question or comment for the net? Please come now. Alrighty, this is K5LK Net Control. Hey, Jim, do you want to, there's some chat in here about feed line losses and so forth in the Zoom chat. Do you want to go to that slide 14 while we're got this and talk about how difference of coax makes? Did you want to cover that briefly?
Yeah, do you want to continue with the on-air portion for this?
Yeah, we've got time. Yes, sir. Go ahead, please.
Okay, so I did some data table here on how does SWR affect the power to your antenna, and these are examples, and I'm assuming quality coax that Bill would be proud to have on his tower. Amazon, not so much. So this is all 100 feet on the slide 14 of RG8X coax. Is a very good coax for HF. And I'm assuming 2-to-1 SWR measured at the antenna. Not so easy to do, I get it, but that's a place where we're taking the measurement. So this is from DX Engineering coax selector chart, and you can see. Let me let it drop. At different frequencies here, the actual loss, which is off the data table in dB per foot or per 100 feet, and the additional loss calculated if you had a 2-to-1 SWR at the antenna, and then the total loss. So the additional loss is well below 1 dB. And the interesting thing to me is, as the frequencies go up, of course, the losses are higher. You need better coax or shorter coax. If you're going to use RG8X like in your car or at a antenna that's close to your shack, it should be fine. You can divide those losses by, like if it's 50 feet, you can divide it in half and so on. It's proportional. And I think it's ironically that the SWR looks better at your rig the worse, the more loss you have in the coax. It kind of makes sense if you think about it. F5EG for ID. So the kind of the bottom line here, RG8X is really good, up through 10 meters, 100 feet, 1.7 dB. That's very reasonable. If you're going to go higher than that, you need to really watch the length or get some better stuff. F5EG for ID. Continuing to slide 15. So at the behest of, who was it? I put some RG58 in here. It's a common coax, very popular, but and cheap. But you can see the losses are higher. At 30 megahertz, you're losing 3 dB around 100 feet, and that's basically half your power is getting into the antenna and half is being lost in the actual by heating up the coax. And if you try to use 100 feet on 440 megahertz, you're basically only getting about 8% of your power up to the antenna. Now, good stuff. An example would be LMR 400. I don't know the cost of it. It didn't seem that ridiculous. But you can see the losses here are quite low. And for 100 feet of 150 megahertz, it's pretty reasonable. 1.8 dB. And then 450, you're starting to maybe you don't want to put your 450 vertical up on top of your tower. You're going to lose all of your gain from the vertical. So again, all of these SWR measurements, the 2 to 1, I mean, if SWR was 3 to 1, the numbers are going to change and get worse. But just 2 to 1's, I think, a good sort of point where people are starting to feel uncomfortable that it's getting a little bit too high. So that's what I chose. So that's pretty much the story on coax. You can get coax much better than LMR 400. If you're going to do a 2 meter or 440 repeater, you're going to run hardline and much bigger coax. Try to get that loss down very low and make a really good match at the antenna. It's worth doing. I'll go to the next slide. It's worth doing if you're on one frequency, or if you're in a narrow band like 30 meters, you want to get that down. So, yeah, I think we've already mentioned all this stuff. So, anyway, that's the SWR and coax. F5EG for ID, so Bill doesn't get mad. And, here we go, references and further info. If you only read one article, the one you can get it off of ARRL, there's a link there. Fairly straightforward. If you want to slog through all of the Smith chart stuff, you can just skip through that. Maybe we'll do a thing on Smith charts someday. That's an easy one to understand. If you want to go to Reflections 3 and read all the way through it, like Phil, W5CPO did, you're going to need scuba gear, I think. It gets deep pretty fast. Anyway, that's a pretty good one. Too low SWR can actually kill you. Anyway, that's all I had. Here's a kind of a story, but we want to get into that later maybe. Anyway, back to you, Bill, AF5EG.
Thanks, Jim. Thanks for covering those slides, that information about coax. Obviously, on this frequency, most people are either on 2 meters or UHF 440, so you are going to get some coax loss for sure. SWR doesn't make that big a deal generally as far as the frequency. But anyhow, this is K5LK Net Control. Any other comments or questions for Jim on his presentation? Please come now.
KN1 HWK question.
HWK, go ahead. Good evening.
Good evening. Awesome presentation. My question is, if I can formulate it correctly, would it be accurate to assert that line losses are compounded by a high SWR antenna? Would that be correct?
Yes, sir. You're absolutely correct.
Okay, thank you.
Hey, Bill, it's Mike. Can you hear me?
That answer your question, Daniel? Anything else, sir?
Nope, that was my question. Just kind of thinking about the way the waves bounce off the end of the antenna and back to the transceiver and then back to the antenna. It seems like that would be the case. So thanks for confirming.
Just a comment. Yeah, we need to be reasonable. I think the point is, trying to get down to 1.1 or 1.2 or even 1.5 with all the effort, it's just, there's not a payoff for it. I mean, that's basically the basic message, I think, for the hams out there.
Thank you, Jim. This is A5LP Net Control. Anyone else want to comment or ask a question about Jim's presentation on SWR? Please come now.
Hey, Bill, we did have a question from KJ5JSC. What's the difference from taking SWR from transmitter versus antenna?
Transmitter versus the antenna.
Okay.
Yeah, did you get that question, Jim, in the chat? What's the difference between taking SWR from the transmitter side or the antenna side? There's been Kelly's been helping out on some of that. I hope you want to answer that or add anything to it.
Bill, AF5EG, I can't, excuse me. I don't think I can see the chat when I'm full screen here. But yes, there's a difference. If you look at, for example, let's look at slide 14. If you take the SWR at the antenna, you're actually measuring the standing wave ratio where the waves are reflected back. If you do it at your rig, the standing wave, the wave that's reflected back towards your transmitter, is attenuated by the line loss. And if you look at the example on slide 14, the SWR reading you will have at your rig is going to be lower, better SWR than you would have at the antenna, because you're sending out a powerful signal, the voltage is high, and the return signal, the red dotted line from that slide early on, is going to be much less. In fact, if you have a long enough piece of coax, the signal may never get reflected back, or so weak it's undetectable, and that would actually make a pretty good dummy load. People have done that in some instances. I hope that answers your question.
Yeah, I think it does, Jim. Yeah, and Kelly had answered. The difference is the coax loss, and you added that, confirmed it. This is K5LK Net Control. Any other comments on Jim's presentation? He is going to stay around in Zoom at the end of the RF net, so we can get into a little more detail. But anybody has a question or comment right now, please come with your call sign.
Okay, G5IAZ.
AG5IAZ, go ahead.
So, additional comment on the taking it at the transmitter as opposed to the antenna. It can be safer if you don't have to climb the tower and try to use your ham radio test equipment at the top of a tower. And Bill had mentioned the importance of buying proper connectors. I kind of want to tell a little story that happened to the Matagorda County repeater system. We bought new antenna and new heliacs to go up to the top of this 300-foot tower, and one of the two systems did not work well at all. And we tried everything we could figure out with VNAs and stuff to try to figure it out. And then one guy came, and while he was looking at his VNA, he happened to reach up and touch the feed line connection on the heliax, and the VNA signal just went nuts. And so one comment I had is, if you're having difficulty and if you do have an analyzer, try wiggling your coaxes around at your connectors, and you might find a bad termination. So that's another thing that's useful on the SWR meter, is to just to verify that your coax connections are good. Anyway, thanks for letting me butt in with the little comments there. KG5IZ.
Comment.
Go ahead, EG.
All right. Yeah, I'm not advocating anybody to climb up their tower to check their SWR. It's just from a measurement perspective, that's where the actual SWR occurs. And, you know, it's going to vary, I guess, down at your rig depending on your coax. But that's a great story, a great idea. I've done that myself where I have a connector not even screwed down good. And again, know your SWR and monitor it, because changes to it, craziness to it, whether it gets high or gets low, a change can indicate you're getting a problem. So I definitely agree with that comment. This is AI5EG.
W5ITZ with a comment.
Go ahead, Bill.
Yeah, one of the ways that you can make it a little bit easier to the antenna is if you're using a tower, a tower, or you're putting a ground point at the bottom of the mast before the antenna goes in, or the coax goes into the house. That's what I did. I've got bulkhead connectors and grounding point right at the bottom of my tower. And if I'm working on a dipole for tuning or something like that, I can connect there. I'm only using about 35 feet of coax from the antenna down, getting a more accurate reading for antenna SWR, and not having to measure through 100 feet of coax that runs through my house and all the way to the shack. So that gives you a little more convenient access to get almost accurate antenna SWR.
Thank you, Bill. Good comments. Absolutely. This is K5LK Net Control for Tech Net number 15. One of many thanks over to Jim, AI5EG, for the presentation and discussion on SWR. He's going to stay around for the Zoom portion, which will continue after the RF portion stops here in just a little bit. We'd like to open the net up now to any amateur radio tech-related questions. Anybody has any tech-related questions around amateur radio on any subject, please come now with your call sign. We'll try to answer them from the group.
Question, this is KJ5 Bravo Lima Victor, Gerardo, Pasadena.
Go ahead, Gerardo. Good to hear you tonight.
Yes, sir. Thank you, Bill. Yes, I had to step away, but I caught some of the presentation on the radio. However, mostly my experience has been on HT, so I'm finally going to move up a bit and get the brand name is XIEGU G106. It's a high frequency, on the cheap side ham radio. And I was just wondering, to read the SWR, do I need to buy something extra, or does the radio, do you know if it comes with the SWR reader, or if I need to buy something separate? That's my question.
Good question. I think you're talking about one of the Zygu radios. May depend on the model number. Can anybody help? Gerardo, does it have a built-in SWR meter? Probably needs to know the model number.
Yeah, copy. The model number is the Golf 106. Golf 106.
Okay, I have a comment.
Okay, Tim.
So, my opinion is that if you're purchasing a handheld radio, you don't need to worry. If it comes with an antenna, you don't need to be concerned about the SWR. There's basically no feed line. The radio should work as is. Excuse me. If you're going to do something like put a radio in your car, you can take a look, at your SWR for that. So I wouldn't be concerned about it. I wouldn't buy any extra equipment for a handheld or a handheld type walkie-talkie thing. It's my opinion.
Does anybody online here on the net have the Zygu X106? I believe that's an HF portable rig. I could be wrong.
Yeah, 5 HPF. Yeah, I'm looking at it online right now. It's a 5-watt QRP radio. I haven't seen anything jump out at me about it having an onboard SWR meter.
And corrected. Nice and corrected.
Eduardo, there won't be any problem. I doubt if it does, but you can borrow an SWR meter from someone and check your SWR. That would not be a problem for you, sir.
Kilo India 510. I haven't checked in yet, but I was just listening. I do have a G106.
Okay, we'll finish up here in just a minute. The person that has the G106, go ahead.
It doesn't have a built-in SWR meter. I just usually bring a Nano VNA. You can pick one of those up for like $50, and then I bring that to the. I activated a part with mine a little bit ago. I got like 73 contacts with it. It's a pretty nice little radio. It works really well if you hook up an external speaker to it, and it really brings that radio to life over.
Okay, that's good to know. Over to you, Joe. Go ahead, W5DSA.
Hey, Gerardo, this is the way I do it. When you're talking HF, I don't really use the SWR meter so much. You're going to most likely, especially depending on your antenna, you're going to be using an antenna tuner, not just checking the SWR, but actually making your antenna resonant. In the process of making it resonant at your transmit frequency, you're going to be using either, I don't know if the D106 has an internal tuner, probably not, but so you probably would want to get like an external tuner, where like this little, I don't know if you can see this. I love this thing. It's a SWRcom, and I'll hold it up here. It's $50, and this is a VHF, UHF, SWR meter and power meter, and it's all digital readout, and it's fantastic. $50 on Amazon. So again, it's a SWRcom, digital VHF, UHF. 125 to 525 megahertz SWR power and SWR meter. So again, that's my experience when you're working HF. Usually you're using a tuner. When you're worried about SWR for VHF and UH flips like mobile antennas, that's a horse of a different color for whatever that's worth. Back to net, W5DSA.
Thank you, Joe. Gerardo, that answer your questions, and we can sure help you. Congratulations, man. Getting ready to get on HF. You will really enjoy it. Anything else, Gerardo?
And negative net control and all the other hams. Thank you so much for your help. Yeah, this helps a lot. And yeah, I'm looking forward to it. So starting to save up my pennies and just get a basic HF rig. And okay, hey, I really appreciate it. And I'll let y'all have a great evening. I'll be clear for now. 73 KJ5 Bravo Lima Victor. Thank you so much again.
Glad to have you. We're getting at the top of the hour, so we're going to go ahead and close the RF portion of the net. But before we do that, we're going to take some late check-ins. As a reminder, at the conclusion of the RF net, we will stay on Zoom. So if you want to come in there, we can continue the discussion on SWR or anything that you want to talk about. And that's www.zoom.crhrc.org. Miss Brenda, are you ready to take some late check-ins? This is K5LK. She's nodding her head. So any late check-ins, please come with signed phonetically twice, name and location.
Kilo India
Papa Alpha Papa and Katie.
KI5 TBT, James McSweeney.
All right, well, Laura would love it. We probably had a triple or a quadruple. Okay, the W2 station, I believe. Let's go first there, and we'll sort them out.
Hey, thanks. This is Whiskey 2, Papa Alpha Papa, Jim and Katie. Tech Net.
Got you, Jim, and I think we had a KI5 prefix. Try it again.
KI5 TBT, Kilo India 5, Tango Bravo Tango.
KI5 Tango Bravo Tango. Any other check-ins? Please come with your call sign phonetically twice, name and location.
Kilo Charlie 7, Juliet Charlie Victor. Kilo Charlie 7, Juliet Charlie Victor. Spencer and Brittany.
Seven JCV, got you. Any others? All right, let's see. Brenda, in the chat, we had KD5RCH. Yoakum, I don't know if you saw that. One last call for late check-ins. And again, reminder, we are going to be on Zoom at zoom.crhrc.org. Be glad to continue on the discussions. Any late check-ins, please come down. I had somebody key the repeater, but I didn't get any audio. You want to try it one more time? All right, we'll go ahead and close the net. And I want to thank everyone that participated in tonight's TechNet number 15, and many thanks to Jim, AI5EG, for leading the discussion. Many thanks to our TechNet team as well. Looks like we had approximately 38 check-ins, great discussion on SWR, and some helping out some folks that are getting on HF. That's what the TechNet strives to do. So we're going to continue on Zoom here. If you have you would like more information about our TechNet team and maybe like to join us, we'd love to have you. Just send an email to info at CRHRC.org. That's info at CRHRC.org. Or you can go to our website. That's at technet.crhrc.org. Technet.crhrc.org. We'll now close the net. Have a great week, everybody. This is K5LK, returning the repeaters back to normal amateur radio news. Hope to see everybody on Zoom. 73. Good night.
You have been listening to a TechNet presentation of the Crossroads Ham Radio Club. For more information on this club, go to www.crhrc.org. For information on upcoming TechNets, go to technet.crhrc.org.